Okay, hello. Um, Super excited to be here. My name is Andrew Morris. I work for a research lab called PSE, which is funded by the Ethereum Foundation. And so, yeah, here to talk to you about MPC, which stands for multi-party computation. Um, yeah, very exciting privacy technology. And yeah, it's in a different order than I thought. Okay, cool. Yeah, so just a little bit more. So we have a team working on this, which I started leading a couple of months ago. And we have a couple of other people from the organization. One of them, his name is Sidor. The other one's name is Yanis. You might notice the lack of photos on here has to do with our whole privacy and pseudonymous thing that's going on. Those were the best photos that they they confirmed those were the photos they would like to be on the presentation. So there you go. Okay, cool. So I'm here to tell you exactly what MPC and what it is all about. And so before I do that, I'd like to get a little bit of a show of hands to get an idea of what sort of amount of knowledge there might already be. So as a control question, could you all please raise your hand if you know, like, not necessarily in all of its glorious detail, but basically if you know what HTTP is, could you raise your hand, please? Great, almost everyone. That's what I was going. Keep your hand raised. Keep your hand raised. Okay, cool. Now keep your hand up if you think privacy is like really important. You can put your hand down if it's only like a little bit important. But yeah, cool. All right, and now keep your hand raised if you know basically what MPC is. Excellent. You guys are in the right place. Cool. All right, so to explain what it is, this is probably an unusual looking slide. Let me tell you, I want to tell you a little story, made up story. Okay, so Candace is watching the news one night and learns that Margaret, an elderly lady who lives just down the street from her, was assaulted and later died in hospital. Candace feels a pit in her stomach. Margaret was a really nice old lady, and she's stunned that something like this could happen so close to home. She sits there thinking. She doesn't know anything about the crime, but she has this nagging feeling that somehow, maybe she could help. But how? Okay, so she's thinking, the police, would have a list of persons of interest and like relevant timeline of relevant events. But, that's the police's information. In a similar way, Candace also actually has her own data that is private to her on her phone, has her location history and all of her contacts. And, maybe there's a connection in here. But, even if she was willing to just walk down to the police station and say, hey, I want to help, maybe I'm connected to this somehow and I would like to help out, that would be awkward, right? The police may very well say, it's not appropriate to do that, even if they have her consent to just start doing that sort of thing. So she feels powerless. Somewhere in her digital records, there might be a connection. She lives in the same neighborhood just down the street. If only there was someone who knew both her private data and the police's information, well, if such a person existed, they could just point it out. But no such person exists, right? The situation seems hopeless. But what if it didn't have to be? I mean, we can't have a person who knows everything, but the connection is there. What if there was a way to find that connection without such a person? Candace wakes up in the middle of the night and is unable to get back to sleep. Desperate, she checks online to find anything else relevant to Margaret's case. It turns out the police are trialing a new information discovery platform that uses MPC. Anyone can download an app on their phone, import their contacts and location history just locally on the phone. Then the app can collaborate on some really funky mathematics, and it can securely calculate whether there's an overlap, whether it's worthwhile to talk to the police, and nothing else, just yes or no, is there an overlap or not? Candace looks sideways at her computer. It doesn't seem possible to do that, but, she decides to give it a go. And don't you know it, it's a match. She should talk to the police. The next day, she goes down to the station for her appointment. It turns out that David, her best friend's father, is a person of interest. The policeman asks, "Is there any chance you know where David was on Tuesday night?" She says, "Yeah, I saw him at my friend's barbecue." The policeman says, "Huh, you don't say. We should talk to him again. Thank you so much for coming down today. That's probably all we have to talk about, but we'll let you know if anything comes up." Turns out that David was part of the suspect's alibi, and with Candace's information, the suspect realized they were caught in a lie, ended up confessing, and they were later convicted. And they couldn't have done it without MPC. So hopefully, and it's a bit of a cheesy story. It is completely made up. Let me be clear. But this is, I think, a good way to kind of illustrate what's going on. People have all kinds of, sensitive information, and there can be extraordinary value that is hidden in the aggregate of that sensitive information. But obviously, we don't want to just trust anyone to have all of that data. To the extent that we do that already, people are uncomfortable about it. It's not ideal that, Google and Apple know so much about us. But yeah, this technology allows us to do that, something that seems impossible. So to clarify, MPC stands for a multi-party computation. In general, what it allows you to do is that people have inputs, private data, multiple parties, and it can be more than two as well. And MPC is a cryptographic protocol that allows you to calculate a function, any function, not just this sort of simple overlap type thing, and just get the answer out. And so in this graphic, I like to think about this with analogy with magic because of how impossible it seems, at least to me, that you could do this. So imagine that we had this kind of power of telepathy, where if people were thinking about where to eat, instead of just offering like, "Oh, do you want to go out for the ice cream?" And the other person like, "Yeah, sure." You could just kind of think about, the options that you would be interested in, and they do the same, and you do some sort of chant or whatever, and out pops the answer like, "Oh, you're both interested in getting burgers," and nothing else is revealed. And this is the kind of thing that MPC allows us to do. And yeah, I think that what is on the table with this technology is, the ability to reimagine privacy. It's like, I'm not sure. I don't think that any of us has been taught the fact that, in order to figure things out, you need to have all of the data, which means that, if someone, the police, are going to find something about your data, they necessarily have to look at the data. And this is actually not true. It's possible to inspect something without looking at it. And I think a way to sort of hack for your brain, I think, that can help you imagine what kind of use cases and what is possible with this kind of thing. Imagine there was like a deity up there that could see everything, but they don't really care either way. It's very boring and principled deity, but they know everything. And you could just ask that deity a question as a group of people. If you have some data and you want to know, and you all jointly want to know the answer to a question based on the data that you have. The deity can look at that information because it knows all of it, and it will give you the answer. Yeah. Okay, so that's sort of all the conceptual stuff. So let's talk a little bit about what's going on and like how we make this work. So yeah, we have this technology called MPC. I don't have time today to go into the underlying cryptography of how it works, but I'd love to come back and explain that more if people are interested. But the nuts and bolts of how we can do this, as how we can deploy this kind of technology as developers. So in order to do MPC, you need something called, you need a circuit. And we use these Bristol format circuits that just kind of specify the different values, how they are combined together in order to produce new values and combine them with subsequent values and stuff like that. And the key thing is here that this is a bit different from the sort of traditional model of computing. In your CPU, the CPU can just kind of like wander around inside code and like, if the color is blue, then go over here. And if the color is red, then go over here and do some different calculation. In a circuit, you can't do that. the circuit has to follow like kind of a fixed layout. And so that is an interesting computer science problem to solve. And yeah, so it can be tricky. You know, our goal is to make this technology as accessible as possible. We really want, you know, everyone to be able to do MPC. So how can we do that? And so, well, we know that everybody writes TypeScript, right? Almost everybody. And not everyone, but lots of people. And so we, as I was just explaining, if you have a circuit, then you can do MPC. And so what if there was something to bridge this gap? If you could write TypeScript and get a circuit, and then you could do MPC with it. I'm very happy to say that this is exactly what we've built. So there's a language called Summon that allows you to write. It's not exactly TypeScript, but it uses the same syntax and has many of the same features. On the surface, it kind of works in the same way. And yeah, so you just write this TypeScript-like program and output pops a circuit for you, and it's boiled all the way down to these Boolean gates, which is what we need. So literally, you type code and you get out and XOR not, that sort of thing. Yeah, so I want to demo that really quick. So over here, so it's as simple as this. So this is an example of a summon program that you can compile. Make that a bit bigger for everybody. So yeah, just, you know, if x is greater than 10, return 10, otherwise return 0. And so we just go summon c foo.ts, and it compiles it for us, and we get output that looks like this. And so it turns out that this program simplifies down to, you know, do the greater than or equal to operation, and then do a multiplication. And so, but this is not the Boolean operation. So there's another step you can do to go all the way down to Boolean. You need to specify how many bits should be in the numbers that you're working with. So you can make this as small or as many bits as you want. So you can do 64-bit if you like, but we're in a very resource-constrained environment, so it's good to use as few bits as possible. So if you do 8-bit, then you get this other circuit out, which does the same thing, but specifically on 8-bit arithmetic. And yeah, that's the output that we get there. Cool, so that's that demo. And so to illustrate what's going on there, so the compiler turns this program into this circuit that looks like this. And this is the Bristol format circuit representation of that, to just, you know, very explicitly say, you know, combine these two values to produce that one with this operation and so forth. And then it compiled it down further into, rather than arithmetic operations, we have Boolean operations. Cool. So once you have that, once you have a circuit, you can integrate that into a project using what we call an MPC framework that refers to the top level thing that you get to interact with. So it's able to bring these pieces together. So we need some sort of platform for building circuits, of which the most recommended one is Summon, but there is like another one as well. And also combine it with sort of an engine for the cryptography, bring them together and just supply them to the API. Very straightforward. You just kind of, you know, you send, the protocol tells you to send bytes to another party, and you just have to do that somehow, probably WebSockets or WebRTC or however you like to do that. And also when you receive bytes from another party, tell the protocol that you got those bytes, and then you can await a promise at the end of it and you get the result. Cool, so let me demonstrate that one. So I'm really hoping that this will work. So this is the repo for this example. Cool. So this is a game called Rock, Paper, Scissors, Lizard, Spock, which you might have seen on the Big Bang Theory. So it's just a little extension of rock, paper, scissors with some extra options. This way, when we find out the outcome, we don't know what the other person did, because there are multiple things that could have happened. And yeah, basically the idea is you can play this game, even though it's a competitive game, you don't trust each other, you can securely calculate who wins when nobody gets to see what actually happened. You just get to see whether you won or lost, and so you can kind of infer you know, multiple possibilities on the other side, and they can do the same thing, but nobody gets to see the full result. So in order to do that, I'm going to pray that this will work. I'm able to connect on my phone. Yep, okay, cool, it works. So let's throw this fancy Spock option and wait for my phone, and I will do that one. And then it calculates. And look at that, we won, or at least the computer side of this protocol won. And I can confirm that the option that I threw is one of those two, but I won't show you because, you know, it's fun that way. Cool. Back to slideshow. Cool. Yeah, so that demo is not too complicated, the MPC Lizard Spock demo, but there is a little bit going on. So we also have a demo which is optimized to be as simple as possible. And it's called MPC Hello. It's the hello world of MPC. So it's a template repository, comes with TypeScript setup, dev server. There's a very simple front end with no framework, so there's not even React or anything like that. You know, you can plug in React if you want to, of course. Uses as a peer-to-peer, end-to-end encrypted system, where like the QR code that I showed, it was actually the symmetric key. And so use the hash of that to connect, to form a common ID to connect you together, but then the clients are the only ones who have the symmetric key and they can encrypt and communicate with each other. The circuit code for driving the computation that happens is included via ordinary project files. And so there's a part of the build system will just like incorporate that in for you. There's also GitHub pages deployment so that you can get started super easily. And that's it. I hope that made sense. Are there any questions? Or do we have time for questions?
We have plenty of time.
Excellent.
Who's first? That's really cool. I don't know how you even found something like this. It's pretty cool. I'm glad that you found a situation to use something like this. I'm just wondering how how secure is it, and how complex can what I'm imagining is the functions all encoded as well, so it's all private, so all the calculations are being done. But surely if the function's static, you know, and you've got a bit of time on your hands, you could sort of reverse your way out of this to figure out what, you know, like whether you guessed rock or scissors, what you know, like how secure is this, you know?
Right.
Yeah.
Yeah. No. So the answer is very secure. The short answer is very secure. But it's actually something that's configurable. It's not something that you know, with enough time and effort you could crack. It's sort of similar to like public key cryptography in that way. Like, I mean, yes, in theory, if you had the universe at your disposal to do computation, you could break the SSL encryption, that sort of thing, but otherwise you can't. So the default config we have at the moment is the security parameter is 40. So that means that the best known attack has a 1 in a trillion chance of succeeding. But you can bump that up. It just costs you a bit more computation. And so you can make it the age of the universe if you want to instead.
Cool. So just have one more question. The like, if you had the function inside of there and you wanted to do something a little bit more complex, like pass the variables off to a LLM model and then check to see if, you know, this guy matches this girl, you know, and then you get the answer back, and then you give them the answer back. Could Summon support something like that, or is it more just for like, this is greater than this, or this is, you know, like this is the square root of this, or something like this?
Yeah. I mean, in theory, it's all computation. Super not recommended to try and do LLMs inside MPC. But like, I mean, you can't sort of call out to an external LLM, if that's what you mean, because
yeah, that makes
it has
sense.
to happen inside this special system. There are actually, funnily enough, there are people who are attempting this kind of thing, and they are kind of getting sort of tokens that come back like very slowly, and I imagine they're much less powerful models, but conversational-ish models, I think, which is strange to me. I'm just like, I don't see how that's it. I mean, maybe like these things sometimes, you know, follow these really great improvement curves, and so if you get 100 times better, then maybe. So
yeah, I guess what happens now is, do we trust the people that are providing the service as well, you know, because we send off the answers to them, and it's like, well, this is all of our processing is handled by a third-party service, but then it's like, oh, well, do we trust, you know, it's like if it was a governmental system where you put in a vote and then it kicks back with the answers to the vote, there's really, you just have to trust that when you put the vote into these people, that somebody, the deity is being honest,
Yeah.
But that's the same with anything. But yeah, cool. Cheers.
Hi, is this somehow related to homomorphic encryption?
Yeah, there's a technology called fully homomorphic encryption, FHE as we abbreviate it. Yeah, it is related. It's a different kind of cryptography, but FHE is a kind of sort of even higher level version of this actually, where the cool thing about FHE is that you can do it in a non-interactive way. So in the demo I showed, both devices had to be online and communicating with each other at the same time. FHE allows you to do the same thing, except you can send data to somebody else and they can't see what it is, but they can perform computations on it all by themselves and then send you the result later, and then only you can see the result, which is pretty cool. But it's like another 100 times slower, which is a problem. So yeah.
But that's a special case of this one.
This one is a special case of that. Yeah, MPC is a special case of FHE. Yeah.
Yeah, I was curious. I guess it's more of a question about like MPC itself than this. But like, does it only work with a sort of finite set of inputs? Because I noticed you sort of had like in the game like 5 inputs that you could have. But could it be like just arbitrary text and you could like I guess is that where the code you've written in Summon like the matching algorithm comes in? So it'd be like find a common substring of length 5 or something like that between 2 blocks of text or.
Got you. Yeah, it has to be fixed. So you agree on the circuit beforehand, and the circuit will be able to handle up to a certain size of inputs. So you could represent strings, and we're actually working on like better sort of data representation and automatic sort of encoding stuff that's bundled into it. At the moment, you kind of you get numbers, and you have to figure out how to interpret those numbers yourself. But yeah, for like a string, you could do sort of like a null terminated string, but then there has to be a fixed limit. So say like 100 characters long, and so the rest has to be like filled with zeros.
Yeah, and even for that string, it's like a fixed set of values, essentially, you're saying. So like if it's represented by a number up to a certain size, you're saying like this circuit can only represent, like X number of values or something like that?
Well, no, like all of the underlying bits can be independent. So if you're putting 100 bits into the circuit, there are like 2 to the 100 different possibilities. And that doesn't mean that you're doing 2 to the 100 in computation. So yeah, no, it's not it's not like a list where every one has to be accounted for. No.
Gotcha. Okay, thanks.
Anyone else? Lots.
Awesome. This is all like really new to me. Sounds pretty cool. I had a few little questions. One clarifying your first example with the police and the lady. My understanding was that both sets couldn't see the data. They just knew there was some answer or some overlap. But in your story, you mentioned the police officer knew which contact was the one that was overlapping.
Yeah.
But I think also in the same story, you said the lady just knew that there was some overlap.
Yep.
So like which one of those was correct?
Yeah, to clarify, so you can set this up so that different kinds of information are revealed to different parties if you want. But in this specific example, I wasn't super clear on the story, but the idea is that the MPC calculates only that yes or no question, and that's revealed the same way to both sides. But what happens in the story is that, that's the justification for talking to the police. And then through like a normal conversation, you can find further details like what's actually going on. But you could use more MPC if you wanted to as well.
Yeah, I mean, so yes, that's so cool. Really cool you clarified that. So we saw that simple program, which is an example program that does something like what you mentioned in that police story, where it is sort of comparing across, potentially quite a range of data sources to try and find some overlap.
Yeah, I mean, you need to sort of gather the data and put it in one place. I'm not sure I understand your question. We have some examples of circuits that are in the Summon repository, so you can look through examples. There's things like sorting, so that you can do things like trying to find this kind of intersection on arbitrary data like locations. So what you would do is use a sort function, which is special. There's a special way to do that in circuits in MPC. You can sort it, and then you go through the list and you find like where the duplicates are next to each other, and then you can say, yeah, that's in common.
I'm going to steal a microphone for one more question. Like, this is your day job and it sounds really interesting and fun. What are some of the like who wants to use this stuff kind of like now? You know, what kind of like use cases are you teeing this up for?
Yeah, that's what we're working on actually. So we're discovering new use cases. There are some interesting examples that have happened in the wild. I think auctions are a really interesting example, and there have been like actual auctions that have happened under MPC, so that you can preserve what everyone's bid is. Sorry, you can keep everybody's bid private, but find out what is the correct and fair result of the auction without revealing any other information. So there's that, and there's also like we're looking at like trying to match people based on common interests or even like different interests. Like if you want to talk to somebody anonymously on the other that has very different political views from you or something like that, then we could like sort of securely match you so nobody else finds out or what the details were that you figured out that you were that. But yeah, lots of things that we're sort of working on. This tech is very new.
So could this be used for kind of like messaging applications? Like, you know how like Facebook Messenger will want to scan your contacts and then upload it to Facebook and then determine who else is on Messenger. Like, could it be used for that, but more privately?
Yeah, that's a really good example, actually. Yeah.
Just going to keep going with the business case questions, sort of tangentially related. Like, what's the compute cost for doing lots and lots and lots of rows of data, like a million rows? Because like genuinely there's like privacy issues around data sharing between organizations in like healthcare, and so many businesses in Australia aren't actually compliant with like Australian privacy standards, and they don't realize it because they have a business need to share stuff that means they're breaching those.
Yep.
So, you're looking at a database or like a database of client information documents, and then some other organization has a similar database of client documents.
Yep.
Doing a compare across two organizations without breaching, that sort of thing. So yeah, the practical use you've talked about, sort of not like, pretty small data sets. What's the compute cost of running like 100,000 rows or a million rows?
That's a very fair question. I'm actually working on specific performance numbers tomorrow. But loosely, it is a problem that like people want to do more calculation than is probably achievable. You can parallelize this stuff though. So if you want to do like a sort of a row, the join or something like that, you can sort of look at it sort of in chunks, stuff like that, and then bring it together. There's also techniques so that you can do an MPC and the outputs are kind of still unknown, but then you can bring those kind of hidden outputs into other MPC calculations and join things together that way. To give you something concrete, in these browser versions that I'm doing, you kind of run out of steam at about 500,000 AND gates, which is not a lot if you're doing something really interesting and like
that relate like the number of AND gates that's related to the bit depth you've chosen.
It's not the the bit width.
Bit width, sorry.
So no, that's so the performance of the circuit is mainly dependent on the AND gates only. The XOR gates, you can have a complete logic system with AND and XOR, and the XOR gates are basically free, not completely, but almost. So we look at the AND gates, and that 500,000 is kind of the limit because there's a problem where it consumes more memory. It does a lot of memory stuff up front, which is not actually necessary, but anyway, it does that. And that calculation takes about 10 minutes as well. So there are also like performance, just heard today about potentially a 100 times speed up on that for like newer methods. So to be confirmed, but that's kind of where we're up to.
Cool. Nice work.
Thank you.
So who invented this MPC protocol? Did you guys come up with it, or is it like someone?
I'm not sure very much of the history. There's been like multiple iterations. So it came out of academia. I think it was first conceived like 20 or 30 years ago, actually, but they just did not have the compute power to do it because of the progress that's happened in hardware, but also the methods. The methods we have today are much, much better. And so it's only in the last like 5 years or so that it's been computationally feasible to do interesting things. And it's only now that we're actually getting like decent developer tooling, like what we're working on. So, yeah.
Just another question following up on a business use case. I used to work in companies where we used to do travel insurance, and then you would have to get medical records for people to make sure that they have like pre-existing medical conditions are not covered. But it's usually, as the gentleman was saying previously, it's just different organizations that would have to share medical records, financial records, and usually comes in via API calls, PDFs, XML, JSON, and then store them very, very securely with lots of human security around it in terms of passwords and all that. Could someday having this as a replacement for, does this person has a pre-existing medical condition and they don't need to upload their patient history, and then we can just cross-examine the data across the two organizations?
I didn't quite get the question. I wanted to answer part of it, but what was the overall question?
The question is like, could this replace fetching something via an API, sending back PDF documents, and to actually then process manually, but just have it like as a programmatic thing where you can connect different entities and cross-examine the data for something specific, not just does it exist in both places?
Yeah, definitely. And the medical insurance one is like, there's an example with that sort of working on, had people at a hackathon who learned about this stuff, have a go at prototyping that kind of thing. Ideally, the model there that we see is like patients having access to their own data. And then, the data comes with signatures and stuff. So it's not on the organizations to share the data with each other and get through the legislative hoops to do that. It belongs to the patient. They have the data. And then they could potentially, even, without this MPC stuff, that would be nice. But with MPC, you could do things like the patient submits to the system under MPC that this is their health data. It comes with a signature from the doctor or whoever, and the MPC verifies the signature is valid, and then you can do things from there, like calculate what their premiums should be, for example, without actually seeing what the data is.
All right, this looks like all the questions. Thank you, Andrew. Round of applause.